Hi, this video is on inverses of a function. Let's go back and review what a one-to-one function is for a moment. Now, from what we've said in the past, this picture says that the picture right over here on the left is a one-to-one function, and the one on the right is not a one-to-one function. And I think this is almost right, except there's a problem here. The definition that I gave you of one-to-one was that not only if it's a function does every x have one y, but if you're a one-to-one function, every y corresponds to one x. So really, this here is a y that corresponds to nothing. So if I wanted to make this a one-to-one function, I would have to cross that out. Now every y corresponds to one and only one x. With that said, I want you to remember that visually, if I want to check something as one-to-one, what did we have to check for? Okay, so if you look at this picture in example number 2, you should see here that there's a y of 3 that corresponds to two x's, 1 and 3, which means it is not one-to-one. When you're not one-to-one, it means your graph will fail a horizontal line test. Now, we're ready to talk about inverses of functions. What do you think of when you think of an inverse? Hopefully you think about undoing. Like, I always think like inverse, you make your bed, then you unmake your bed. They're inverses of each other, they undo each other. So what we want to look at is that functions that are inverses. So we're going to start off with a function f of x, which doubles a number and adds 8. Then we're going to look at another function, g of x, which subtracts 8 and then divides by 2. Think about this a second. If you double something and add 8, wouldn't you be undoing it if you subtract 8 and then divide by 2? So intrinsically, these two functions, f and g, should be inverses. So let's start by plugging all these different values of x into f of x. So if we plug in 0, we get 2 times 0 plus 8 is 8. Plug in 2, we get 2 times 2 is 4 plus 8 is 12. Plug in 4, we get 2 times 4 is 8 plus 8 is 16. Plug in 6, we get 2 times 6 is 12 plus 8 is 20. Plug in 8, we get 2 times 8 is 16 plus 8 is 24. So our domain right now is on the left. Those are the values we're plugging in. And our range is on the left. Those are our outputs. Now let's plug into g and see what happens if we take the outputs of f and plug them into g. So I'm going to take 8 and now plug it into g. 8 minus 8 is 0, divided by 2 is 0. 12 minus 8 is 4, divided by 2 is 2. 16 minus 8 is 8, divided by 2 is 4. 20 minus 8 is 12, divided by 2 is 6. And this should be a 24 here. 24 minus 8 is 16, divided by 2 is 8. Now I want you to study these two pictures over here, and I want you to notice what's true. Domain of f is the range of g. Range of f is the domain of g. So the first thing that you should notice when you're studying inverses is that in an inverse, the domain and range are switched. So with that said, we can go to the next page and we can say conclusion 1, that when we have inverses, that the domain and the range are switched. The domain of one function is the range of its inverse. Okay, now I want you to turn this video off in a second, and I'm serious, I want you to do it, and I want you using the functions above f of x and g of x to calculate f of g of x and then g of f of x. We've already talked about compositions, so this should be easy peasy. Turn off, and when you're ready, turn this back on. Let's check how you did. So in the first case, we're going to plug g into f. So f of g of x will equal, now again, we're going to plug g wherever there's an x in f. It's going to then be 2 times the g is now our input plus 8. So think about this. F of x is 2x plus 8. And our input now for x is x minus 2. The 2's are going to cancel. Minus 8 plus 8 is 0. So we're going to be left with just x. Now let's do this on the other side. Let's do g of f of x. Well, g of f of x, so I'm going to write that down. G of f of x means we're going to plug f of x wherever there's an input in g. So g starts off with the input x, which in this case is f of x, minus 8 over 2. If we simplify this, we're going to see that the plus 8 and the minus 8 cancel. The 2's cancel, and you're just left with x. Which leads us to our definition of an inverse. A function f of x is the inverse of g of x if and only if f of g of x is equal to g of f of x is equal to x. In fact, this is our second conclusion. If we want to verify that two functions are inverses, to verify, oops, that doesn't look very good. Let's see if I have an eraser here. Oh, here we go. I'm talking to myself, boys and girls. Okay, to verify, wow, I did it again. Let's try this one more time. To verify two functions are inverses, you have to check that f of g of x equals g of f of x equals x. And I got to tell you, it's not enough that f of g of x equals x. There are such things as called one-sided identities, or inverses, excuse me. You have to check the other side too. So in the homework or the classwork, which you're going to look at tomorrow, you want to know to verify, you're going to have to check that this statement is true on both sides. Okay, now the last piece here. What happens when two functions are inverses? What do their graphs look like? Well, let's start off with f of x. I'm going to go up 1, 2, 3, 4, 5, 6, 7, 8. That is the y-intercept, and it should go up to over 1, because that's our slope, which means it's going down to over 1, down to over 1, down to over 1, down to over 1. And I'm not very good at drawing this very straight, but I'll try. That's the first line. And then if I want to do x minus 8 over 2, that's really the same as 1/2 x minus 4. And that's what g of x would equal. So we're going to start with the y-intercept of -4, 1, 2, 3, 4. And we're going to use our slope up 1 over 2, up 1 over 2, up 1 over 2. And this would be our other function. Now I want you to look and see what you think they're symmetric about. Study the graph a minute, and I'm sorry it's a little bit messy. It might help if you look at it, excuse me, I'm going back here, on my calculator. These are the two functions, and they're symmetric about a certain line. What is the line? Okay, now I'm just going to put this in here for now, Control G, and I'm going to put in X, and there's my line of symmetry. And this is what's true. If you are representing two functions that are inverses, they should be symmetric about the line y equals x, which makes sense. Think about geometry when you did reflection over the line y equals x. The rule was to switch x and y. So if you switch x and y when you're forming an inverse, it means that you are, ta-da! Okay, switch x and y, you're forming the inverse, but you're also reflecting over the line y equals x. So our third conclusion is inverses are symmetric about the line y equals x. Our step to finding inverse is very, very simple. Step 1, switch x and y. And then step 2, solve for y. Sometimes we use the notion f inverse of x for inverse. So f of x is the function, its inverse can be called f inverse of x. So if you look here at our first example, f of x equals x cubed plus 1. F of x is a fancy word for, oh, I don't know why that's coming up. Let's close that, cancel, is a fancy word for y. So if I want to form the inverse, I'm going to switch x and y, so it'll be x equals y cubed plus 1. And now we solve for y, so x minus 1 equals y cubed. But let's go a step further. We don't want y cubed, we want y. So y is going to be the cube root of x minus 1 when we form the inverse. We have to cube root both sides. Technically, you might see this notation, f inverse of x equals the cube root of x minus 1. Last question here. Okay, and here we go. Sorry about that. I want the inverse of f of x equals x squared. Now, x squared looks like this. Is this a one-to-one function? Hopefully you said no. If that's the case, I want you to think, will its inverse be a function? Just keep that under your hat from now, and then we'll take a look. Okay, this is my y, and that's my x squared. I want you to turn this off for a minute, and I want you to find the inverse function, and then turn this back on. Welcome back. Okay, this is why that's x squared. When we do the inverse, it's going to mean that x equals y squared. When we solve for x now, or excuse me, y, we have to take the square root of y. But I want you to remember, when we're solving, we have to take both the positive and negative square roots. And this is the trick. So f inverse of x will equal both the positive and the negative square root of x. With that said, I want you to look at this picture on the next page. This is my original function. Sorry, it's in black. The radical x is in pink. The negative radical x is in green. I want you to notice here that this inverse is not a function. I can definitely see that it would not pass a vertical line test. Okay, if I drew a line from the top to the bottom, you would see x's with two different values of y. So our original function, y equals x squared, was not one-to-one. So its inverse, when we form it, will not be a function. So thinking about this, I want you to think, do you know what a function's inverse is, how to form it, and be ready. Bring your green books tomorrow to practice this in class. Remember, green books in class tomorrow. Have fun. Bye.